5 factors of soil formation at parent material. There's the climate, there is the topography, you have the biology of the system, and you also have time.
We're here in one of the oldest parts of the island. This particular island is 12 million years old, and we're here to study the end point of soil pedogenesis. So there's a number of different endpoints, but when you have lots and lots of rainfall combined with high temperatures and long time periods, ultimately you lead to the production of the Oxisol soil, which we have in front of us. It's this deep red soil. It's super rich in iron oxides, which gives it that classic colour, and it also contains clay minerals which are almost stripped of their goodness, and that leads us to a clay mineral called kaolinite. And it's on the top of a ridge, and consequently we've had all of the rainfall which has been washing this material out, and now we are in the situation where we're actually suffering from soil erosion at this site. Yeah, so what we've done is, with all of that leaching, all the water passing through the soil profile, we've lost all the calcium, pretty much the sodium, the potassium and the magnesium. All those base cations are gone, and what we're left with is a lot of aluminium here and a lot of hydrogen. What that's led to is the pH of this soil has gone down to about pH 4.5, which is really low. Most plants are not adapted to growing under those conditions because the aluminium is toxic to them, and the aluminium becomes soluble at pH 4.5, which makes it even more toxic. Well, there's many types of this type of soil around the world, particularly, for example, in tropical regions under tropical rainforest like Brazil, and they grow, very good yielding soybean yields there. And one of the ways to do that is you have to add lime to the soil, classically, to raise the pH, which puts calcium back into the system, as well as raising the pH so that aluminium doesn't become toxic anymore. But you also need to put a lot of nutrients back into the system just to keep the system going. And it also helps to have organic matter in these soils. These soils are very low in organic matter generally, because the temperature in the water is quite high. It's conducive to losing organic matter. So you need to make sure that at all times you're constantly replenishing the organic matter supply of that soil system. Originally this was a smallholder farming site. We had goats on here, and the goats classically ate all the vegetation, exposed this Oxisol soil, which is really prone, to losing its goodness anyway. But when you strip off the vegetation cover, you leave it exposed to the rain, and the soil just washes off into the valleys. Once you lose that vegetation cover, of course, you lose all of that nutrient capital that's contained in the top 10 centimetres. Almost all the nutrient capital is contained there, particularly in this soil. Once we lost that nutrient capital, we then couldn't grow any more plants here. So the erosion carried on and on and on, and we've lost about 6 or 7 metres of soil at this particular site. People have tried to remediate it here. It's not that they've left it. In the past, we tried to rely on science to be able to answer some of those questions, to how to remediate a site like this. And we used eucalypts here, which are classically trees, growing in Australia on those incredibly old acid soils, millions of years old. But even the eucalypts couldn't survive here. The site was too exposed. And I think the only things that are surviving here now are actually the plants that are adapted to being here. Clearly they're naturally adapted, and there's one particular plant called Erica arborea, which is quite good actually at restoring this site, at least in some parts of it where we still have some soil left. This site is also a flagship site for looking at mineral weathering. This site is built on basaltic columns. So these classically, the basalt columns are hexagonal shape, and here we can see, because it was so eroded here, we've lost so many metres of soil, we've basically gone back to the mineral weathering front. Normally when you look at the soil, the top soil is millions of years old, but down at the bottom of the mineral weathering front, that is time zero essentially. Yeah. So what this site has revealed is that we can see some remnants of the topsoil here, but we can look back millions of years right through that weathering series, which is incredibly unique. And that patterning that you can see in the soil, that hexagonal type patterning, is due to the way that you have the mineral onion skin weathering of those basaltic columns. Certainly where you look at where all of the soil has been eroded right back to the bedrock surface, we are resetting the soil cycle again. So we are back to entisols, particularly in some parts here. Soil takes an incredibly long time to form, But yes, it's so easy to lose it. And I think that is a lesson that has been made many times in history, and we keep repeating the same mistakes.